let us see the most important topic. One of the most important topic corresponding to measurements, that is loading effect. Many of the people will be studying measurements without knowing what is loading effect and where we can see this and all. Now let us see and let us get a basic idea, and we'll go what is this effect and all, and how to eradicate this thing, etc, etc. We'll go in this lecture. Fine. Now so today we are going to cover sensitivity. What is sensitivity? Then what is loading effect and how to overcome it. These are the topics we are going to cover in this lecture. Fine. Next, first topic to be studied now is sensitivity of an instrument. Fine. Before going to sensitivity of an instrument, let us see. I'll show you a kid. I'll show you some fun I'll show you, and I'll let you know what is sensitivity. You will easily understand what is sensitivity after showing that. Now, see this kid. See this kid. See this person. Once, let us see again. He is giving an input here. That means he is trying to fear him, and on the other hand, he is fearing and he is trying to cry. Right? So, here he is giving input. The other person is giving input so that the small guy is crying. So, we can say that the person, this small kid, is very sensitive, right? Highly sensitive. Right? We generally, if consider our friend. If we say some small word, if he feels or hurts a lot or overreacts, then we will say that he is very sensitive guy. Right? Similarly, the same thing is being happened here. This person is giving some input, and here this guy started crying. This small kid started crying. Right? So, for small input, there is a large output. Right? So, we can say that this small person is highly sensitive. Now, let us see the same sensitivity in terms of for a measurement, actually, for a measuring instrument. Fine. Now, so sensitivity can be defined. It is a ratio of change in output of the instrument to the change in input of measured variable. Right. So, for small change in input, how much change in output is coming? For small change in input, how much change in output is coming? That is what we call it as sensitivity. Sensitivity is called the same way. Fine. Now, here he is saying higher sensitivity indicates that the system can respond to even the smallest input. That is what before the image you can see clearly. This small guy. See, he is giving a very small input. He didn't say at least something, but he started crying. So we can say that he is highly sensitive. So for our measurement also, for our measuring instrument also, we can say that if we give small input, suppose we say 0.1 volt, we are giving input as 0.1 volt, and so that the pointer starts moving, immediately pointer starts moving. So we can say that this instrument is having very high sensitivity. Right? So we defined sensitivity as change in output with respect to change in input. So we can say that for small change in input, what is the change in output? That is called sensitivity. So sensitivity can be defined as change in output divided by change in input. Fine. And we already said that higher sensitivity means that the system can respond to even the smallest input. Right? So for smallest input also, it can generate some output. We saw that guy also. Right? Now, it is determined by the ratio of resistance in ohms to the full scale reading in volt. So, he is also defining it as ratio of resistance to voltage, right? Full scale voltage. Fine. So, we can also modify this as 1 by VFL by R. Fine. So, we can write it as 1 by, what is V by R? I. Current, right? 1 by V by R is, V by R is I, where it is at full load, right? Therefore, we can define sensitivity as 1 by full load current. Fine. So now, what is the unit? So, unit is, what is the unit of resistance? Ohm. Divided by what is the unit of voltage? Volt. So this is the unit of sensitivity. Ohm per volt. So also we can define it as ampere inverse is also an unit. This is also an unit, and this is also an unit. Fine. Many of the people will stop it here only. Many of the people will stop it here only. Ohm per volt. But this is also an unit, because in some exams I saw this option was also asked for sensitivity unit. So please remember this thing. Just we will do 1 by volt per ohm. We will be getting 1 by ampere. Therefore it is ampere inverse. That's the thing. Fine. Now let us move to the next part. So sensitivity is also defined as I already said this, change in output by change in input. Now sensitivity is given as resistance. Here for a meter we will be having two resistance. That is, for voltmeter we will be having a series resistance. For voltmeter we will be having a series resistance, and also internally meter will have some resistance, right? This series resistance is called a multiplier. We all know these things and all, right? And meter will have some meter resistance. So it is the sum of two resistances divided by full scale reading in volt. So voltage reading. So we can define the unit as ohm per volt, or we already said now it is ampere inverse. Fine. Now simplifying, we will be getting sensitivity equal to 1 by full load current, full scale current. It is equal to ohm per volt or ampere inverse. This is the thing how we will define sensitivity. Fine. Till now we are okay, right? We got what is sensitivity. We saw that guy, small guy who is crying and all. From there we define what is sensitivity and all, right? From now, if you get the topic of sensitivity, remember that small guy. In measurements, whenever you see the sensitivity topic, immediately remember that small guy, how he is crying. You will get the idea very easily, right? From now you should not forget what is sensitivity and all. Fine. Now let us go to the second part. Now let us see what is loading effect. This is the key concept which we are going to now discuss now. Now see what is loading effect. Before going to loading effect, let me find voltage across this and voltage across this. Fine. So let me find what is the voltage across 50 kilo ohm. Here we can easily apply voltage divider rule, right? Voltage divider rule says that total voltage into same branch resistance. It is 50 divided by total resistance. I'll write the formula. Let it be V2. So V2 can be written as, if we take this as V1, then we can write it as total voltage in V into same branch resistance. Same branch resistance, wherever we are finding the voltage, that branch resistance divided by total resistance. Since they are connected in series, we'll add them. We'll just add them, right? So R equivalent divided by wherever we are finding, that is the resistance we have. Now after simplifying, we will be getting 150 into 50 divided by 150, right? So the answer will be 150 and 150 gets cancelled, and the voltage will be 50 volt. And what is the voltage across 100 kilo ohm? It will be total voltage into same branch resistance divided by total resistance, right? So we will be getting 100 volt. So here it is 50 volt and here it is 100 volt, right? This is the way we got that equation. Now if we connect a voltmeter across 50 kilo ohm, we should get, the voltmeter should read 50 volt, right? So if we connect a voltmeter across this 50 kilo ohm, the voltmeter should read 50 volt. Let us see that. See, we connected a voltmeter across and it is reading 50 volt, right? This is ideal voltmeter. Now, this is ideal voltmeter. Ideal voltmeter will have infinite resistance, right? Infinite internal resistance. So I will remodify this thing. 50 kilo ohm, 100 kilo ohm, and here it will be infinite internal resistance, means it is simply open circuit like this, so that all the current will start flowing like this only. It won't come here because current always flows in closed path, but there is no closed path here. Here just there is voltmeter and internal resistance is infinity. Ideal voltmeter infinite internal resistance, right? So it is just open circuit. It will just read the voltage. For open circuit we can find voltage, but current is 0. That is what we know. So current will be 0. Current is 0. So there is voltage. So that voltage will be 50 volt, right? That is what we read here. 50 volt is coming. Now let me take two cases. Here I dealt about ideal voltmeter. No, let me take, but practically there is one more thing. Practically the internal resistance will not be infinity, right? Practically it will not be infinite internal resistance, right? Am I right? Then we need 2 voltmeters. Let me take 2 voltmeters. I would like to take 2 voltmeters. Voltmeter A has a sensitivity of 1000 ohm per volt, and voltmeter B has a sensitivity of 20,000 ohm per volt, right? Let me take the cases. Case 1, voltmeter A has a sensitivity of 1000 ohm per volt, right? Now let me calculate the resistance of this. For this we already saw this thing. We already saw this circuit. Here it is 100 volt and here it is 50 volt, right? Now let me find the resistance of this voltmeter, internal resistance of this voltmeter. So Ra is equal to 1000 ohm per volt into, what is the voltage? 50 volt. Now what is the thing it is coming? 50,000, right? 50,000 ohm or 50 kilo ohm, right? 50 kilo ohm. Now if I modify the diagram, it is 100k and this is 50k, and again we have one more 50k internal resistance, right? Here there is voltmeter, along with that it has internal resistance. So if we simplify this thing, 50 in parallel with 50, we will be getting 25 kilo ohm, right? So let me simplify that thing. 100, 25, okay, and input is 150 volt. Now what is the reading? Corresponding to this? Here it is, voltmeter is there, still voltmeter will be there, and we simplified the internal resistance, that's it. Still voltmeter is connected. Now if we will find the voltage across 25k. What is the voltage? Total voltage into same branch resistance divided by total resistance, 125. Fine. 21 ones are 21 5s are. It will be 30 volt, right? So instead of showing 50 volt, it is showing 30 volt now. Voltmeter A is showing 30 volt now because it also had some internal resistance, and when we simplified that thing, it got reduced to 25 kilo ohm. That is why it is showing less reading actually. Then can you guess what is the reason why it is happening? Because it had some internal resistance. Now here it had an internal resistance of 50k, right? Say suppose I amp is coming. Suppose I ampere of current is coming. So it will be divided here. After coming here, it starts dividing. Here it will be I by 2. Here it will be I by 2. Therefore, voltmeter is also taking some current actually. But in ideal case, just before we saw, in ideal case, it is not taking any current, right? It was not taking any current. It was just open circuited because the internal resistance is infinity. But here it has some internal resistance. Therefore, we can say that it is taking some current. So it needs some current for its operation also. So it created some voltage drop. That is why Instead of I amperes of current, it is taking only I by 2. That is why we are getting only 30 volt. Hope you got my point, right? Hope you got my point here. This is the concept of dividing currents. This is just a concept. Since they are in parallel and equal resistances are there, current will divide equally. That is what I said just now. Fine. In case 1, we got for 1000 ohm per volt sensitivity voltmeter, we got voltage across 50k ohm is 30 volt. Fine. Let me take case 2. Let me take case 2, which has an internal, sensitivity, voltmeter sensitivity is 20,000 ohm per volt. So, if we find voltmeter internal resistance RB, it is 20,000 into 50 volt, right? Just before we got the voltage across, this is 50 volt and this is 100 volt. It was calculated initially. Now, what is the value? I think it will be this much, right? 405050, 2 5s are 10. Done. So this can be written as 1000 kilo ohm. Fine, 1000 kilo ohm. Now here it is 1000 kilo ohm and here it is 50 kilo ohm. If we do this simplify, it will be 50 into 1000 divided by 50 plus 1000. And if we simplify that, I think after simplification we will be getting 47.6 kilo ohm. 47.6 kilo ohm. Now let me find the voltage. Across 50k ohm. Right? We have connected that across 50k, so we need to find voltage across 50k. Now if we find total voltage is 150 into same branch resistance. Same branch resistance is 47.6 divided by total resistance 100 plus 47.6. Initially, let me draw you for better understanding. Let me draw something. Here it is 100k and here it is 50 and here it is 1000 kilo ohm, right? 1000 kilo ohm. Now if we simplify this thing, we got 47.6 kilo ohm, right? Now here there was voltmeter also. That is what I am doing now. If we simplify this thing, we will be getting approximately 48.4 volt. 48.4 volt if we simplify this thing. So voltmeter B is reading 48.4 volt and voltmeter A was reading 30 volt. Voltmeter B is reading 48.4 volt, which is closer. Actually, ideal value, true value is 50 volt, right? In ideal case, we got 50 volt, which is near, which is more accurate, We can directly say that 48.4 is very near to 50, so it is more accurate. So we can conclude here a point that voltmeter B, which has more sensitivity, is more accurate and it has very less loading effect. I'll show you what is the true definition of loading effect now. See, when a voltmeter is connected across a resistor to measure voltage, that is what we did, right? This was done just before, right? This was 100k and this was 50k, and here it is input is 150 volt, right? To measure voltage, voltmeter draws current for its working. In case 1 we showed I by 2 concept and all. Then as voltmeter internal resistance is in parallel with the resistance, so we showed just now. We had here we will be having some internal resistance and here we have already some resistance, so both will be in parallel with the resistance. Resultant resistance reduces, so that is what happened here. Resultant resistance, here it is 50 kilo ohm and it is 1000 kilo ohm. So when they are in parallel, the resultant resistance is being reduced to 47.6. that is what he said. Then voltmeter reads less than the actual value. Actual value is 50 volt. It should read 50 volt, but now it is reading 48.4 volt. In case 1 it was reading 30 volt only, right? So this is called loading effect. This is called loading effect. Here also we can say that I amp is coming, and here some current is going, and here also some current is going. I1, I2 currents are going. But ideally, this is the ideal case. Ideally, it is open circuited. It is just like this, open circuited. So all the current I amp is coming, and all the current will go like this only through the 50k ohm, and it will not go any, not even point, not 1 ampere of current will go through this voltmeter, because it is ideal, and ideal voltmeter will have infinite internal resistance, right? So we can say that sensitivity of ideal voltmeter is, since resistance is infinity, we can directly say that sensitivity of ideal voltmeter is infinite, right? Infinite. So in order to reduce this loading effect, what we have to do? We have to increase the sensitivity, right? See, when it was 1000 volt, the voltmeter was reading 30 volt. When it was 20,000 ohm per volt, it was reading 48.4. And when it was infinite ohm per volt, it was reading 50 volt directly. So I'll write the cases here. When it was sensitivity voltmeter reading. First, when it was 1000 ohm per volt, it was reading 30 volt only. When it was 20,000 ohm per volt, it was 20,000 ohm per volt, it was reading 48.4 volt. And when it was infinity, it was reading exactly 50 volt. Fine. We need this voltage. We need this much accuracy. 100% accuracy we need. But we got practical cases, we got 48.4. So we got approximately some 98 or 97% of accuracy. That is enough, right? Ideally, we can't get actually 50 volt actually. But in practical cases, we can get this much value. And still if we increase 30,000, 40,000, 50,000 like that, we can still increase the value more accurately, right? So we can conclude that in order to reduce this loading effect, the sensitivity of meter should be as high as possible, right? We got a conclusion that to reduce loading effect, highly sensitive meters are preferred, right? This is the reason. Fine. Now, how to overcome it? We already said this point just before, right? How to overcome? It should be noted that the meter with higher sensitivity gives reliable result. That's what I showed just now. This is particularly true where voltage measurement is done in higher resistance circuit, right? Since we took 50 kilo ohm, 100 kilo ohm, these are higher resistances. So for these cases, we need highly sensitive meters in order to eliminate loading effect. This is called loading effect. All this called loading effect. I explained 3 cases. This is ideal case, and this is practical case 1, and this is practical case 2. And before that, we saw what is sensitivity and all. Right? Now we saw how to eliminate. This is the main thing. That is why I explained what is sensitivity in starting only. Now we know what is sensitivity, what is loading effect in voltmeter, and how to overcome it. Right? Hope you understood this. If you have any doubt, you can comment in the comment section. I'll let you know. Thank you.